Alright, in this warm-up, we're going to draw the quadrilateral with the given vertices. Then we'll determine the most precise name for the quadrilateral using some of our formulas. The points are C, -5, 0, A, -3, 2, V, 3, 2, and S, 5, 0. Notice that spells Cavs. Go Cavs. It's my favorite basketball team. So here we go. I plotted the points and connected the dots. And I have what looks to be like a trapezoid. But again, it's asking for the most precise name. So is this just the trapezoid, or is this an isosceles trapezoid? If we wanted to prove it was a trapezoid, it just has to have one pair of parallel sides, which it does. AV is parallel to CS because they both have a slope of 0. We also want to check and see if AC is the same length as VS. So for that, we'll use the distance formula. So first I'll start by finding CA. I'm going to plug the x1, y1, x2, y2 values into the distance formula and then carry out my calculations. I get CA equals 2 squared plus -2 squared. Remember, when you square a negative, it becomes positive. So this is CA equals the square root of 4 plus 4, which is the square root of 8, which we know how to factor down, or we know how to simplify that radical expression to 2 root 2. Alright, let's find the length of VS. Same process. Going to plug those x coordinates and y coordinates into the distance formula and carry out our calculations. When we do that, we get the same thing. We get square root of 8, or in other words, 2 root 2. So what type of quadrilateral, or what's the most precise name for this quadrilateral? It's an isosceles trapezoid. 6-8 notes. Applying coordinate geometry. Naming coordinates. In the diagram below, rectangle KLMN is centered at the origin with sides parallel to the axes. Find the missing coordinates. So we're going to do 2 examples. We're going to do one with numbers in the coordinate plane, and then we're going to do one with variables. So let's focus on the left side of the screen right now. The only coordinates that we're given is the coordinates for point L, which is 3, 2. Remember, the x comes before the y, so x is the left to right movement on our screen here, and the y-axis is our up and down movement. So to get from the origin, because we're centered at the origin here, so to get from the origin to point L, we went right 3 and up 2, which is why both our values are positive. For point K, we need to go left 3 and up 2. So that gives us a value, that gives us the coordinates -3, 2. Alright, so what about point N? Well, that's going to have the same x value as K, right? We have to move the same distance from the origin to the left to get to N, which is -3 units, and then down 2 units from x. So that would be -3, -2. Alright, oops. How about point M? Point M, we need to go to the right the same number of units as we did for L, which was +3, and then down from x, so +3, -2. Okay, so let's go look to the right side of our screen. Here we have point L given again, except this time they're just calling it A, B. Well, let's go in counterclockwise order again. So if we go with point K, we would have to go the same units to the left as we did to the right with point L from the origin. So that'd be -A, and then we need to go up the same amount of units, which is B. So -A, B. N is going to be -A, -B, because we're going left A and down B. And then M, we're going to go right A, so A, and down B, so A, -B. Alright, for this one, we need to use properties of parallelograms to find the missing coordinates for Q. Alright, so for this one, if we look at this parallelogram, we know that these sides are parallel and these sides are parallel. If we want to find Q, this point right here, we need to know how far it is from the origin. So if I were to draw a line straight down at 90 degrees, I would really like to know what this missing length is. Is there a way to figure that out? Well, if you think about it, this missing length, if I go from the origin up to an extension of the parallelogram at 90 degrees, it's this length right here. That length is B. So from point O, or the origin, to point P, we have to go right S units and B units. That's what this is. So our x coordinate is going to be not 5, I misinterpreted that, it's an S. It's going to be S plus B. Our y coordinate, Q, for Q, is the same as R. It's the same height, right? So the y coordinate is C. For this example, we have a quadrilateral inside another quadrilateral. MNPO is a rectangle, and TV, U, and W are the midpoints of the sides. Find the coordinates for T, V, U, and W. All right, well, if I want to find the coordinates for point T, that's halfway between O and M. So I can use the midpoint formula to find the coordinates for T. So if the coordinates for the origin are 0, 0, then I just plug those into the midpoint formula and I get T is equal to 0, comma B. When you take 0 plus 2b, you just get 2b divided by 2, and those cross out and you just get b, so 0, comma b. Let's go to coordinate u. Alright, so to get to u, we go right, from O to P is 2a, so if this is halfway, that would be half of 2a, which is just a, and then we're not going up at all, so the y coordinate is 0. V, to get from the origin to point P, that's 2a, that's the same as V, and then to get from P to N, that's the length there is from 0 to 2b, so 2b, and half of that would just be b. W, remember that W is also going to be half, the x-coordinate for W is going to be half of 2a, which is just a, and then the y-coordinate would be the same as M and N, which is 2b. Alright, so for this last example, the diagram here shows a trapezoid. We wanted to figure out if it's an isosceles trapezoid. So again, just like our warm-up, we need to decide, okay, is segment RT congruent to segment AP? If they are, then we have an isosceles trapezoid. We know that RA is parallel to TP because they say it's a trapezoid, and a trapezoid's got one pair of parallel sides, so we're going to assume those are our parallel sides. And then we're going to run the distance formula to find the length of RT and AP. When we do that, we have to work with variables and be very careful in our calculations. You can see when I solve for RT, I get the square root of the quantity of negative a plus b squared plus negative c squared. Remember that when you square a negative, this value is always going to end up being positive. And then AP, notice I get something very similar. The square root of the quantity of negative a plus b squared, that's the same as RT. And then it's just positive c squared. Well, is positive c squared and negative c squared the same thing after you square it? Like negative c times negative c will give you positive c squared, and c times c will give you c squared. So these are in fact the same. So we know that the trapezoid is isosceles because its legs are congruent. Your homework for 6.8 is on mathexcelforschool.com, due Sunday at midnight.